Hello and welcome back to AlgoTutor YouTube channel. I am Akshay Jain and I am a software engineer. So in this lecture, we are going to start with selection sort in an array. So let's try by exploring what is selection sort. Suppose we are given an unsorted array. I've explained this, what is unsorted and assorted in the previous lecture. If you have missed it, please go through the previous lecture and try solving your bubble sort first, then come to selection sort. So let's try by taking an example as 12, 3, 0, 2, 11 and 9. So we are given an array of let's suppose anything. So we have taken an array of int. Now what we have to do, we have to consider, the first step is we have to consider that our array is of two parts. The first part is sorted array and the second part is unsorted array. So initially okay, the sorted array will be empty. Initially the sorted array will be empty. An unsorted array contains all elements. So basically this is our unsorted array, and suppose at 0th index or at hypothetical index we have a sorted type of array. Now what we have to do, by the name is suggesting selection, what we have to do, we have to, second point, we have to select what? We have to select the minimum element. We have to select the minimum element. If you have to arrange it ascending order, if you have to arrange the array in descending order, then you have to select the maximum element. So we have to select what? Minimum element. You have to select minimum element from what? Where are all the elements present? In the unsorted array. So we have to select minimum arrays from all the unsorted array. Now after selecting the minimum array in the unsorted array, so what is the minimum array? What is the minimum element? Minimum element is basically the first element of the sorted array. So what we have to do, third point. What we have to do, third point is swap at initial index. And what is initial index? Our sorted array. Sorted part of array. Okay. Sorted part of array. Then what? Then what? If we have placed that minimum part to its correct position, then we do not have to consider that element again. So we have to start another. We have to traverse another. We have to look for another minimum element from unsorted array. So fourth step is repeat step 2 and step 3 from next element, because the first element is considered to be sorted because it is the minimum element from the array. So minimum element has to be placed at the first position itself. So this is the algorithm of selection sort. Let's try by doing a dry run over here. So let's take an example. 12, 3, 0, 2, 11 and 9. Okay. So what we have to do, we have to select the minimum array, minimum element. Which is minimum element? 0. Now I have considered the first part. This part has to be sorted, and these all are unsorted. So what I am going to do, I will place it at 0th index. So what I will do, I will just simply swap it, or kind of do anything. So I will just simply swap with the index position I equals to 0. It's basic thing. We have to swap at the beginning. So I'll just swap. Now it will 0. It will be 3, 12, 2, 11 and 9. Now what is the yellow part is sorted and the white part is unsorted. So we have to look for the minimum element in the white part. So which is the minimum element? It is 2. What we have to do? Now our I has become 1. Why I has become 1? Because this part is sorted. Now the next part, the beginning of the unsorted is the new sorted. We'll swap this. So it will become 0, 2. Now it will become 12, 3, 11 and 9. What we'll do now, we'll look for the minimum element in the white part. So which is the minimum element here? 3 is the minimum element here. I has become 2 now. So what I will do, I'll swap 3 and 12. So it will give me 0, 2, 3, now 12, 11 and 9. Okay. So again, I have to look for the minimum element in which part? We have to look the minimum element in the white part. So which is the minimum element in the white part? Which is I equals to, which is 9, and I has become now 3. I will just simply swap it. So it will give me 0, 2, 3, 9, okay, 11 and 12. give me 11 and 12. Now I is 4. What is minimum element in white part? It is 11. So I'll just swap 11 with 11. Now you can see that there is only one element left and it's the largest element. So basically I have to perform till n minus 1 only. Yani means 0th index, 1 index, 2 index, 0, 1, 2, 3, 4. N is what? N is 5. Last index will be 5, but I have to perform only till this. Okay, so I have to perform only till this. Okay, n is 6 basically. Last index is 5, so I have to go till n minus 2 index. I have to perform operation till n minus 2 index, and within the second loop will be traversing through all because I am looking for the minimum element in the all part. So the pseudocode will look like this for I equals to 0 to n minus 1. We have to pick minimum index as I. Now we'll traverse another loop for I equals to for j equals to I. Okay, so we have to start with the minimum index part. I don't have to take the backward side. I will not start with 0 because I don't have to start with minimum looking from again. So I will just start from I till n, and I will perform the operation if I found greater, min. Depending on the condition, I will update it. I will update the min index and I will swap the following parts. So this is the pseudo code for selection sort. Now let's try by exploring its real code and we'll understand what its time complexity and what's its space complexity. So this is the selection sort code. Let's start by exploring the main function. We are given an array data name. The name of the array is data. It contains 12, 3, 0, 2, 11 and 9. Okay, so I've calculated size over here and I've passed the array and size to the selection sort function. Now selection sort function starts with 0 and goes till n minus 1 as I go. It is less than n minus 1, which is clearly stating that we have to go till n minus 2. Okay, we have to take n minus 2 as part because n minus 1 element will be sorted at the end of the array by itself. Now I have taken the minimum index as I. Minimum index basically takes the sorted index. It is a sorted index we have taken. So I've taken I. Initially I is 0, so initially a minimum index will be 0 as we have performed this over here. What I've taken? Initially we have taken 0. This part. Initially it was 0, so that's why I have taken 0 over here. Now I'll start by running another loop which will go from I plus 1 because till I it is sorted and unsorted starts from I plus 1 to the last point of the array. Because we have to find what? We have to find the minimum. If at any points our array of at minimum index is greater than the array of j index, what I have to do? I have to update minimum index as j. I have to update minimum index as j because I found that index, and at the end I will just simply swap both the values as I've done here. What I did, it was rj, so I found j and I performed this and this, I swapped it. So basically this is you have to do every time. So after performing, let's take the swap function. Swap function, I hope all you know. I will assign temp to A to B and B to temp. So this is how it will swap. I am assuming that you know swap function very well because we have done bubble sort earlier and in that lecture I've explained swap function very well. So after this, it is saying cout, so it will print, and print is basically, I hope everyone knows it. So let's start by running it, and it is printing 0, 2, 3, 9, 11, 12. So I hope you understand the selection sort algorithm, and the time complexity of this algorithm would come out to be big of n square again because we are running 2 nested loops in this also. So I hope you understand this lecture, and if you understand, please thumbs up this video. Do comment what you are looking for in next video. I will try to make that one again. And till then, happy coding. We'll meet you in next video with insertion sort. Chalo. Okay. Bye bye.